numbers 1 and -1,
Yeah.
right? And in order to get the input signal PRBS, we need a time vector, the transpose of the time vector, and a U that is going to be the random signal. Is going to be 1 and -1, a vector, right?
Yes.
1 and -1. So after that we have the input signal. We just need to simulate. It's gonna be like that. This is the input signal. This is the same name that we have on the code.
Yeah, also note that for this simulation, the most important things are, if you look at the stop time, just beside the box labeled normal, it's n time ts. And can you open the simulation configuration parameters? No, I mean in the simulation menu.
Simulation.
Yeah.
It's right here. The
No,
code or the
in the model. Yeah, the
Yeah.
simulation menu,
Okay.
configuration parameters.
Yep.
And you look at the sampling time here.
It's TS.
The sampling time has to be ts.
Yeah, it has to be TS, the same variable constant that we use in our code.
And one more thing to note here in the code is your time vector goes from 0 at steps of ts to n-1 times ts, because if you do n times ts, then you will be off by 1 because you're starting at 0.
Yeah, it's gonna be 121, so we don't want that.
Want that.
We want just 128.
Okay, go ahead, run it, and let's see what happens.
So this is, as I tell you, this is the transfer function that we have from here, that we generate the discrete transform, and this is the output. So if we first run this part of the program and then run the simulation, so the output is gonna be in the workspace. So if you go to workspace and output, it's gonna be like that.
Yep, and since our input was a bunch of random ones and -1s, although this output looks bad, it is actually good. And if you get any other output which makes more sense or looks good for this lab, it actually means it's wrong. So this is correct.
Yep. So after that so this is the correlation analysis. This is the formula that I showed you before on the lag boot. This is in the lag boot. So this is Y is gonna be the output of the simulation block. So this is gonna be the output. So I name Y in this case. Those two commands that you see here, the open, and just open the block and I simulate the block. So the same name is right here, and then just I get the output, and then lambda is gonna be 1 because Chayo explained you how to use it, how to do everything, and just run the program. Yep. So because I have it right here, the J, my output of the simulation part is gonna be J. So I just run and it's gonna look like that. This is the after the correlation analysis.
Yeah,
Your output is gonna look.
that is after the correlation analysis.
Okay, after you're done with the simulation part, so go ahead and we have to do the GP6 part. So we just need to do the same thing as previous lab. Let me show you. We just need now, instead a step input that we used before, right? So just we need to substitute this for a input signal PRBS, and we just need to take the output. So the same thing, we just need to run this part of the program in order to get the input signal PRBS. We did the same thing for the simulation part, and now we are ready to simulate the program. So we already have everything connected. So the same thing that we did in previous lab. So here we turn it on, and for potentiometer 5 we have 593, and for 6 we have 400 0.4. so that was the setting that we had before, right? So, and then you go OPR and run the program. Let me build again. Yeah, it's ready.
Now it's built and ready.
And I got the program. So you have to notice that I'm just running the program using length with is 212. It's gonna be
512. It's gonna be 2 raised to 8.
Yeah, 512 is gonna be 28, right?
Yeah.
And I'm using the sampling time of 0.001. So I just run the program, open the scope, remember, and I just run the program, and this is the output. On the simulating block, if you notice, the stop time is gonna be the length times the sampling time. So let me show you the output workspace. Just go file, save to workspace, and then I just have to find the name. Is that the input signal? Not that one. I think this is. So it looks kind of the same.
There is the output. Yeah, it looks pretty much the same.
Yep. So after you have the output, just you need to use the same thing. We need to calculate the correlation analysis. The formula that we have is the same thing, just you need to take the output from the block diagram that you have from the scope. For me, it's gonna be H, it's gonna be the output. So after that, you just need to write the code for the correlation analysis and just run it. Yep. So the output is gonna be F because I run it both. So I'm going to block them at the same time. It's gonna. So this is the output from after the correlation part for the simulator and the calculator part. The blue signal is the simulation part, and the red signal is the GP6 after the correlation analysis. They looks almost the same, right?
Yeah. Can you zoom the initial part?
Right here.
Yeah. If you see, the red one has some magnitude difference than the blue one, but that is okay because it matches pretty closely. So this is one of the runs which is possibly the best run, like the N of 512 and TS of 0.001 worked out perfectly. But in order to get here, You will have to do a lot many experiments, like try out various ends and try out various TSS, and we leave that to you. Well, thank you very much.
Thank you.